Video is the second part of ISRO VSSC Technical Assistant Electronics Engineering previous year question paper with detailed solution which was held in 2019. Question number 21. In the circuit given below, what is Vout? Answer is option D, 4 Vm. Here, in one cycle, capacitor will charge and in another cycle, it will hold the peak value. When we cascade the same configuration, we get a multiplier. The voltage multiplier converts AC to DC. The given circuit is a voltage quadruple. Consider the given figure. In the first negative half cycle, D1 is on and capacitor charges to the peak of input voltage Vm. That is Vc1 equal to Vm. During the negative half cycle, D2 is on, that is Vc2 equal to 2 Vm. In the next negative half cycle, D3 is on, that is Vc2 equal to 2 Vm. The given circuit is a voltage quadruple, hence Vout equal to 4 Vm. The next question is 22. Find the current through the 2 ohm resistor in the given figure given below. Option is B. 0.625 ampere is the correct answer. From the circuit, after converting 1 ampere and 1 ohm resistance, that is current to voltage source transformation is performing. That is, the voltage source in series with the resistance can be converted into the current source in parallel with same resistance and vice versa. Here, convert 1 ampere and current source in parallel with 1 ohm resistor into corresponding voltage source series with the same resistance. V equal to I into R. V equal to 1 ampere into 1 ohm, which is voltage converted is 1 volt. Applying KCL at node A and consider voltage at node A is V. V minus 1 by 2 plus V by 2 plus V minus 2 by 1 equal to 0. After solving, we will get voltage V equal to 5 by 4, which is 1.25 volt. We need the current through 2 ohm resistor, that is I through 2 ohm equal to V by R. We got V equal to 1.25 divided by the value of resistance is 2 ohm. After solving, we get the current is 0.625 ampere. Circuit shown below is used to implement the Boolean expression y. Which of the following combination of values of j and k will result in y equal to ab? First, find the Boolean expression of the given circuit and then compare the expression with our required final expression. Consider the circuit. The output of OR gate with j and a input is j plus a and output of NOR gate is a bar plus k whole bar. The final output is y equal to j plus a into a bar plus k whole bar. After solving, we get y equal to a k bar. To get y equal to a b, k will have to be b bar. That is, if k equal to b bar and j is any value, that is y equal to a into b bar. That is ab. Hence answer is j equal to 1 and k equal to b dash from the given option. Question number 24. The period of the signal x of t equal to cos 2 pi t cos 4 pi t minus sin 2 pi t into sin 4 pi t is option A, 1 by 3 second. We know that the purpose of periodic signal is to get the harmonics. That is, n omega naught represents the nth harmonics of omega naught. Given signal is x of t equal to cos 2 pi t into cos 4 pi t minus sin 2 pi t into sin 4 pi t. It is a combination of two signals, that is x of t equal to x1 of t minus x2 of t, where x1 of t equal to cos 2 pi t into cos 4 pi t. We know that cos a cos b equal to 1 by 2 cos a minus b plus cos a plus b. That is 1 by 2 into cos 2 pi t minus 4 pi t plus cos 2 pi t plus 4 pi t, which is equal to 1 by 2 cos 2 pi t plus cos 6 pi t, which is equal to 1 by 2 cos 2 pi t plus 1 by 2 cos 6 pi t. Similarly, x2 of t equal to sin 2 pi t into sin 4 pi t. We know that sin a sin b equal to 1 by 2 into cos a minus b minus cos a plus b. Hence, here which is equal to 1 by 2 into cos 2 pi t minus 4 pi t 4 pi t minus cos 2 pi t plus 4 pi t. After solving, we will get 1 by 2 cos 2 pi t minus 1 by 2 cos 6 pi t. Substitute equation 2 and 3 in equation 1, we will get x of t equal to 1 by 2 cos 2 pi t plus 1 by 2 cos 6 pi t minus of 1 by 2 cos 2 pi t minus 1 by 2 cos 6 pi t. After solving, we get cos x of t as cos 6 pi t. Compare equation 4 with x of t equal to cos omega naught t. Here we get omega naught equal to 6 pi. So the time period t equal to 2 pi by omega naught. This is the equation of time period, which is equal to 2 pi divided by 6 pi, which we will get 1 by 3 second. Next question 25. A sawtooth waveform is applied to a comparator as shown in the figure given below. What is the duty ratio of the waveform at V outer? Answer is option C, 75%. In open loop, an op-amp acts as comparator. Actually, duty cycle. It is the ratio of a time a load or circuit is on compared to the time load or circuit is off. The duty cycle, also called duty factor, is represented as a percentage of on time. A 60% duty cycle is a signal, means that signal is on for 60% of the time and off for 40%. Therefore, equation for duty cycle equal to T on divided by T on plus T off. We know that V0 equal to A into V1 minus V2. Here A into V in minus 2.5. Hence substitute two different values for V in. So consider case 1. If V in greater than 2.5, then equation 1 will be positive. That is, at that time we got output V0 equal to plus V sat, which is equal to 15 volt. In case 2, if V in less than 2.5 volt, then equation 1 will be negative. V0 equal to minus V sat, which is equal to minus 15 volt. Figure A shows the output characteristics we drawn according to case 1 and case 2. From the output characteristics, we get T on equal to 10 minus 2.5 volt, which is equal to 7.5 volt. T off equal to 2.5 volt. Therefore, duty cycle equal to T on by T on plus T off into 100, which is equal to 7.5 divided by 7.5 plus 2.5 into 100, which is 75%. Question number 26. In an amplitude modulated system, a sinusoidal carrier signal of 1 MHz is modulated by a 10 kHz sinusoidal signal. If the lower sideband and the carrier are suppressed, and if the amplitude modulated signal is sampled for further processing, what should be the minimum sampling frequency for baseband sampling? Answer is option D, 2020 kHz. We know the time domain equation of singleton SSB is S of t equal to AC AM by 2 into cos 2 pi FC plus or minus FM of t. From here we can understand the equation of upper sideband is S of t equal to AC AM divided by 2 into cos 2 pi FC plus FM of t, where the equation for upper sideband is S of t equal to AC AM by 2 into cos 2 pi into FC minus FM of t. Given carrier frequency is 1 MHz and message signal frequency is 10 kHz. That is FC equal to 1 MHz, which is equal to 100 kHz. Sorry, 100 it is not 100, 1000 kHz, and FM equal to 10 kHz. Carrier and lower sideband is suppressed, so the signal passed is only upper sideband. Therefore, S of t equal to AC AM by 2 into cos 2 pi 1000 plus 10 into 10 raised to 3t. The total frequency of the signal passed is 1000 plus 10, which is equal to 1010 kHz. The minimum sampling frequency required is Fs equal to 2 FM. FM is the maximum frequency of message signal, which is equal to Fs equal to 2 into 1010 kHz, which is the answer is 2020 kHz. The next question is 27. Identify the gate G1 and G2 respectively in the figure given below to get Y equal to ABC. The option A is the right answer, NOR and NAND gate. To get y equal to ABC, we have to eliminate the complement of A dash and B dash from the input of the gate G1. This is possible with either a NAND or NOR gate at G1. Consider both cases. Case 1. With NAND gate at G1 and OR gate at G2, we get y equal to A bar B bar whole bar plus C. By De Morgan's law, we get y equal to A plus B plus C. This is not the required case. So consider case 2. With NOR at G1 and at G2, we get y equal to A bar plus B bar whole bar into C. By using De Morgan's law, we get y equal to ABC. This is the required equation. So G1 is NOR and G2 is AND gate. In the next question 28, in the circuit given below, what is the operating region of the transistor if it has a beta value of 100? Option A is the correct answer, saturation. Answer. Consider case 1, checking for active region. From the given circuit, V equal to 0 volt, which is grounded actually the terminal. Applying KVL from supply to emitter through the base. Minus 5 plus IB into 1K plus 0.7 equal to 0. After solving, we get IB equal to 4.3 milliampere. We know IC equal to beta IB. Beta value given is 100. So 100 into 4.3 milliampere equal to 430 milliampere. Applying KVL at the collector side, we get minus 5 plus 430 milliampere into 1 kilo ohm plus Vc equal to 0. We get Vc equal to 5 minus 430 milliampere. This does not make any sense. So the transistor is not in active region. So consider the second case, checking for saturation region. Assume Vc equal to 0.2 volt. Applying KVL at the collector side, IC equal to 5 minus Vc, which is 0.2 divided by 1K, which is 4.8 milliampere. Now calculate base current, IB equal to IC by beta, which is equal to 4.8 milliampere divided by 100. We will get 0.048 milliampere. Then find base current by KVL. We got base current by the equation, from the equation. So next we are calculating by KVL. Modulus of IB equal to 5 minus 0.7 by 1K equal to 4.3 milliampere. Here 4.3 milliampere is greater than 0.048 milliampere. That is modulus of beta is greater than modulus of IC by beta. Hence the transistor is in the saturation region. Consider question 29. In the circuit given below, what is the output voltage Vout? Assume ideal diode and the circuit is at steady state. Option B is the correct answer, 0 volt. Consider first op-amp circuit, figure A. Applying voltage division at a non-inverting terminal, we get V plus equal to 1 into 10K divided by 10K plus 10K. We will get 0.5 volt. Since op-amp is negative feedback, we can apply virtual ground, that is V plus equal to V minus. Applying KVL at V minus, 4 minus 0.7 divided by 10 kilo ohm equal to 0.5 minus V naught divided by 10K. That is V. After solving, we will get V naught equal to minus 3 volt. Consider the next op-amp circuit, which is the configuration of differentiator. Consider the figure B. V naught of t equal to minus RC d Vn of t divided by dt. This is the equation of differentiator. We substitute the values of R, C and Vn. Here for the second circuit, Vn is the output of first circuit, which is minus 3 volt. Differentiation of a constant is 0. So we get output V naught equal to 0 volt. Consider the question 31. A super heterodyne receiver with an intermediate frequency of 450 kHz is tuned to a signal of 1600 kHz. The image frequency is option A, 2500 kHz. Actually, the signal which causes interference is called image frequency after mixing in the receiver part of radio. The image frequency and intermediate frequency related as Fsi equal to Fs plus 2Fi. Substitute the values of Fs and Fi, we get the image frequency. Here IF intermediate frequency is 250 kHz and Fs is 1600 kHz. After substituting, we will get Fsi equal to 2500 kHz. Question number 32. A 240 volt single phase AC supply is fed to a load resistor of 100 ohm through a thyristor. If the thyristor is fired at 90 degree, what is the power consumed by the load? Option A, 144 watt is the correct answer. In a single phase half wave thyristor circuit, the RMS output voltage is given by Vrms equal to Vm by 2 root pi into root of pi minus alpha into 1 by 2 sine 2 alpha. Given firing angle alpha is 90 degree and maximum phase voltage Vm equal to 240 root 2 volt. Then calculate the RMS voltage by substituting the firing angle and maximum phase voltage Vm in the equation. Vrms equal to 240 by root 2 divided by 2 root pi into root of pi minus pi by 2. We can write alpha, that is 90 degree, into pi by 2 plus 1 by 2 sine 2 into pi by 2. After solving, we get the RMS voltage is 120 volt. The power consumed by the load P equal to V square by R, which is equal to 120 into 120 divided by 100, which is equal to 144 watt. Question number 33. A 4-bit digital to analog, that is DAC, gives an output voltage of 5 volt for an input code of 1111. What is the output voltage for an input code of 1100? Option D, 4 volt is the correct answer. We know that resolution is the minimum change at the DAC output. Resolution equal to step size. Therefore, percentage resolution equal to step size divided by full scale output into 100. Full scale output is the total voltage level given to the DAC, or in simple terms it is calculated as FSO equal to total steps into step size, which is equal to 2 raised to n minus 1 into step size. Here given output voltage as 5 voltage and input is 1111. Converting 1111 in binary form into decimal form, we get 15. Resolution equal to 5 volt divided by 15, which is equal to 1 by 3. The new input given is 1100. The decimal value corresponding to 1100 is 12. Therefore, resolution equal to 12 into 1 by 3, which is equal to 4 volt. The next question is 34. In a series RLC circuit fed from an AC source, the amplitude of the voltage across the resistor is 120 volt and the amplitude of the voltage across capacitor and inductor is 50 volt each at a resonance. What is the amplitude of the source voltage? Answer is option B, 120 volt. We know that for a series RLC circuit, the net magnitude or amplitude of the source voltage is given by V net equal to root of VR square plus VL minus VC whole square. VR equal to voltage across resistor, VL equal to voltage across inductor, and VC is the voltage across capacitor. At a resonance, the net impedance is purely resistive, resulting in VL equal to VC. Given VL equal to VC equal to 50 volt, VR equal to 120 volt. Therefore, the net amplitude or magnitude of the source voltage is given by V net equal to root of VR square plus VL minus VC whole square, which is equal to root of 120 square plus 50 minus 50 whole square. We get the answer of 120 volt. The next question is, what is the equivalent capacitance of the circuit given below across the terminals A and B? Option A, C is the correct answer. Before analyzing the circuit, we want to discuss about the capacitance equivalency. That is capacitance in series. The equivalent of all capacitance in series is calculated as 1 by C equivalent equal to 1 by C1 plus 1 by C2 plus up to 1 by C in, where Cn. Where if n capacitors are of same value, then equivalent will be C equivalent equal to C by n. The equivalent of all capacitance in parallel is calculated as C equivalent equal to C1 plus C2 plus up to Cn. If n capacitors are of the same value are connected in parallel, then the equivalent will be C equivalent equal to n into C. We can analyze our circuit. From the given circuit, the last three capacitors are in series. Therefore, C equivalent 1 equal to the value of capacitor is 3C divided by number of capacitor 3. Therefore 3C by 3 equal to C. Then the equivalent circuit is figure 1. Two capacitors C by 2 are in parallel. C equal to C by 2 plus C by 2, or NC by 2, which is equal to, we will get C. C equivalent in parallel, consider figure 2. C equivalent 2 is parallel to C equivalent 1. That is C equivalent 3 equal to capacitor C plus C, which is equal to 2C. Consider figure 2. Two capacitors of value 2C are in series. C equivalent 4 equal to 2C by 2, that is C by N. Here the value of C is 2C, therefore 2C by 2 equal to C. Then the equivalent circuit is figure 3. Two capacitors of value 2C and C are in parallel. C equivalent 5 equal to 3. It is 2C. 2C plus C equal to 3C. Then the equivalent circuit is figure 4. 3C capacitors are in series. Therefore, CAB equal to, that is equivalent resistance equal to 3C by C. That is C by 3. C by N. Here value of C is 3C and value of N is 3. Hence we get the value as C. Next question number 36. In 8085 processor, register B contains 0x03 and register C contains 0x04. What is the content of accumulator after the execution of the program given below? MVI A, 0x00H, loop ADC, DCRC, JNZ loop halt. The answer is option C, 0x0C. Given B equal to 0x03H and C equal to 0x04H. The first instruction MVI A, 0x00H means move immediate 0x00H to the accumulator register. That is the content of A is 0x00H. The next instruction loop add B means that the addition of the content in B register with the accumulator and store the result in accumulator. That is A equal to 0x00H plus B equal to 0x03H. We get the content of accumulator is 0x03H. So the content of A becomes 0x03H. The next instruction is DCRC. Means that the content of C is decreased by 1 and the result is stored in the C register. The next instruction is JNZ loop. Means jump to the loop if the content of C is not 0 and if the content of C is 0, then immediately run the next instruction in the program. Here C is 0x04H. So the loop repeat itself 4 times. After that, content of C becomes 0 and program will stop by the instruction HLT. Here how the loop works is shown like the first loop content of A is 00 plus 03, which the content of A is 03 and content of C is 3. 03. And the next on the next loop, actually on that time, it will check the content of C is either 0 or not. Actually that time the content of C is 3. So we will again continue that loop. Then value of A becomes 03 plus 03, which is equal to 06. And the accumulator, the value of content is 06 and the value of content is C register is 02. Again the loop works. The accumulator get the value of 09 and decrement the value of register C to 1. Again accumulator will get a value of 12 and the content of C will get 0 after decrement. Then next go to the execution of program will stop. Therefore the content of accumulator after the execution will 0x0CH. The question number 37. The energy stored in an iron coil is 2000 joule and its copper loss is 40 watt. The time constant of the coil is, let I is the current in the iron core. Energy stored in iron cored coil is, the equation is 1 by 2 Li square, which we in question we get The energy stored in the iron core coil is 2000 joule. And copper loss is 40 watt. We know the equation of copper loss is I square R. To get the time constant L by R of RL circuit, divide the two equations. Half Li square divided by I square R equal to 2000 by 40, which will get L by 2R equal to 50. We need the time constant L by R. So take 2 to right hand side. Then we will get L by R equal to 100 second. 38. A battery of 7.5 volt 4 ampere hour is formed by using cells of 1.5 volt 1 ampere hour and internal resistance of 0.2 ohm. If a load of 1 ohm is connected across the battery, find the current through it. Option C, 6 ampere is the correct answer. We can design the battery of 7.5 volt 4 ampere hour by using cells of 1.5 volt 1 ampere hour and an internal resistor of 0.2 ohm. We need 4 slots with the number of cells n in each slot as n equal to 7.5 divided by 1.5, which is equal to 5. Internal resistance of each slot equal to 5 into 0.2, which is equal to 1 ohm. Therefore, the total internal resistance of the battery becomes RT. RT equal to 1 by 4. 1 by 4 because the resistors are in parallel of equal resistance, which is equal to R by number of resistance. Here the value of R is 1 ohm and the number of resistance is 4, which we will get RT equal to 1 by 4, which is equal to 0.25 ohm. Now IL equal to 7.5 volt divided by total resistance, which is RT plus RL, that is 1 ohm plus 0.25, which is we will get 7.5 divided by 1.25, which is equal to 6 ampere. Question number 39. For the circuit given below with the initial condition y2, y1, y0 equal to 0, 0, 1, what is the output after 3 clock cycles? Option B, 101 is the correct answer. This is the truth table of D flip-flop. Clock D, Qn plus 1 is the next state. When the clock is 0, whatever the value of D, the output of D flip-flop is the present state Qn. When clock is activated 1, D is 0, Qn plus 1 is the 0, that is reset, same state. When clock is 1 and D is 1, the next state is 1. Given initial condition y2, y1, y0 equal to 0, 0, 1. The circuit given is a synchronous counter because the clock signal is applied to all the flip-flops at the same time. From the circuit we get the equation for D1, D2, D3. D1 equal to y1 XOR y0 and D2 equal to y2 equal to Q1 and D3 equal to y1 equal to Q2. Here the present state 0, 0, 1. After XORing y1 and y1 and y2, sorry, it is y1 and y0. Y1 D1 equal to y1 XOR y0. 0 XOR 1 equal to we get 1 and D2 equal to y2 0, D3 equal to y1 0. This is just to copy the statement as next statement and consider the present statement as in the second clock 1 0 0. Then D1 equal to y1 XOR y0, that is not y2, that is y0. We get 0 XOR 0 is 0. D2 equal to y2 1, D3 equal to y1 equal to 0. Just copy this answer 0 1 0 to next state and the third clock cycle 0 1 0. Consider D1 equal to y1 XOR y0. 1 XOR 0 we will get 1. D2 equal to y2 equal to 0. D3 equal to y1 equal to 1. The next state is 1 0 1. This 1 0 1 is the output after 3 clock cycle. Question number 14. For the common emitter amplifier circuit given below, what is the quiescent collector current? Assume that the base current is negligible and VB equal to 0.7 voltage. Answer is option 4 milliampere. Given structure is a voltage divider by a circuit. From the circuit we get VCC equal to 9 voltage, R1 equal to 10 kilo ohm, R2 equal to 2 kilo ohm, RE equal to 0.2 kilo ohm, RC equal to 1 kilo ohm. Given that the base current is negligible, so beta will be of high value. Generally beta varies from 50 to 150. Here we assume beta equal to 100. Then Thevenin equivalent circuit will be VTH equal to VCC into R2 divided by R1 plus R2, which is equal to 9 into 2K divided by 9K plus 2K, which is equal to 1.5 voltage. And the Thevenin equivalent resistance RTH equal to R1 into R2 divided by R1 plus R2, which is equal to 10K into 2K divided by 10K plus 2K, which is equal to 5 by 3 kilo ohm. Applying KVL to the base to the emitter resistor of the Thevenin equivalent circuit, minus VTH plus RB into minus VTH plus IB into RTH plus VBE plus IERE equal to 0, which is equal to minus 1.5 voltage plus 0 plus 0.7 plus IE into 0.2 equal to 0. After solving we will get IE equal to 4 milliampere. We know IC directly proportional to IE. IC equal to alpha IE, that IC equal to beta divided by 1 plus beta into IE, which is equal to 100 divided by 1 plus 100 into 4 milliampere. Approximately we will the answer is 3.6 milliampere, approximately 4 milliampere. Based on the options below, it is nearer to 4 milliampere. So choose 4 milliampere as the answer. But to get this value, beta should be 100. If beta is 15, then that value will be very low. So assume beta is equal to 100.